Hey guys, welcome to my YouTube channel. I'll be solving LeetCode 75 list using GoLang. So let's look at today's question. Longest subarray of ones after deleting one element. Given a binary array nums, you should delete one element from it. Return the size of the longest non-empty subarray containing only ones in the resulting array. Okay. Return 0 if there is no such subarray. Okay. If there is no such subarray, we need to return 0. Okay. So basically this question, if you are following this LeetCode 75 list, is very similar to this question, max consecutive ones 3, which is just one question before it. So here they are asking you to find maximum number of consecutive ones wherein you can flip at most k zeros. So I've already solved this question in the channel. So in this question what they are asking is you need to delete one element. So basically if you are considering a subarray like this, you can count 10 because they have told like you can delete one element. So basically this is same as the previous problem with k being 1, like you can maximum have 1 0 in the window. And also since they're asking you that you can delete while returning the size, you just have to return the size of the window -1 because they expect you to delete, so that's why you need to return size of the window -1. Let's go to the drawing board and properly understand it. Yeah, so this is the example that they have given, and for this what is the answer, like maximum size of the window. So if you see, if you take so yeah, if you take this window, if you take this entire window as entire array as the window, that is let me write in a different color. Yeah, so basically if you consider the entire window, it has just 1 0 here. So basically what they have told, you can delete one element. So if you delete this element, what is the size of the window? The window will become consecutive if you delete this 0 1 1 1. So the answer will be 3 because 3 is the length of this window. So let's take another example. Nums is equal to 0 1 1 1 0 1 1 0 1. So what is the answer for this? So here as I told you, you can delete at max 1 0. So consider this window. So if you consider this window, this it has just 1 0, and as I told, we can delete at most 1 0. So consider this window. So 1 2 3 4 5 6 is the size of this window, but since we are deleting 1 0, 6 minus 1 5 will be the result after deleting that 1 0. So this is basically the answer. So basically just imagine this as the previous question, which was max consecutive zeros 3, but consider k is equal to 1 here. You can consider at most 1 0, and the result, the window what you will be considering, consider the size of window -1 because the question is framed in a way that they're telling you you need to delete one element. So while recording the window size, you have to just record size of the window -1. That's it. So now let's look into the brute force of how you would solve this, and then I'll explain you the sliding window approach. So the brute force is also quite simple. So go through all the possible subarrays. So for I is 0 to 1, for j is equal to I plus 1 to n. So basically go through all the subarrays. It will be n square if you go through all the subarrays. And after going through subarrays, consider subarrays, consider subarray where count count is equal to count is nothing but number of zeros in that current window, in the current subarray basically. So this is nothing but number of zeros. So consider all the subarrays where number of 0 is lesser than or equal to 1, and record size of the window minus 1 for all of them. So record size of window minus 1, and obviously you will have like a global res, and keep updating this global res by the size of window minus 1. So this would be n squared. So let's not do that. Let me tell you the sliding window approach which we could follow. Okay, let's erase this off, and then yeah, sliding window. So the sliding window I'm going to discuss here is exactly same as the previous question, so there is nothing new. So let me do this. Yeah, 1 1 0 1. So same L and R will be here initially at the beginning. So keep moving your R here, R will come here. Whenever you encounter a 0, increment your count. So count was initially 0. Now since you saw a 0, you increment your count to 1. Again move your R. Um, Move your R, and then as and when you're moving the R, you need keep recording the size of the window. So because the number of zeros in the window is less than or equal to 1, so all these windows are valid windows, so you need to keep recording the size of the window. So how do you record the size of the window? You do R minus L plus 1, that will give you window size. But in this problem they are telling you can delete one element, so skip this minus 1 and just do R minus L, because they are asking you to delete one element. So in this global res, keep counting the number of windows like that. So basically what I am trying to tell is, so when R was here, what is the size of the window? So it will be 1. So it will be 1, and then when R is here, the size of the window will be 2. So like that, when R is at the end, size of the window will be 3, and only update res if the size of the window is more than the previous value. So at final, res will be 3, so you just need to return that. And in this example I didn't get a chance to like move L, but I think let me take a different example so that I can show you, like, even if you have to move L, how you could solve this. So let's take a better example. 0 1 1 1 0 1 1 0 1. Okay, that's a bigger example, L and R. Okay, count also will have 0 initially. Keep moving. So initially only it is 0, so count will be 1. So keep moving, 1 1 1, and you will keep continuously calculating the size also, because all these windows are valid because it's less than or equal to 1. So res at this point will be how much? 1 2 3 4, so it will be 3. So then again res will move here. Now the count will again increment because it's a 0. Now the window is no longer valid because count of ones can be only 1. So move L so that you surpass the first 0. So move your L so that you surpass the first 0. So what does that mean? Move this L to the next position, because there was a 0 here. Move the L to the next position. So now the window will again, where were we in the previous window? I think we were here. We were here, yeah, because the previous 0 was here. So this window is again valid, see, because there is only 1 0. Size of this is again like 1 2 3 4, so 3, so we don't have to update it. Keep moving it, R, and again keep updating 4 and then again move it here, and it will become 5. Okay. And now again, when you move the window, there is one more 0 here. Sorry, the count previously was 1, and now how many zeros are there? Now it becomes 2 because there are two zeros. Since it became 2, we need to increment our L. Our L was here, we need to surpass the very first 0. So the very first 0 is this. So after you surpass it, L will become here. It will be here, and then again keep moving L R. So here size is 3, so maximum is 5 anyway, you don't have to update it. So this is how the sliding window logic will work. Now let's go to the editor and write the code. Code is also quite simple. L comma R, both will be 0 initially, and we'll need a res also, which is the final result. All of them will be 0, and then for R is equal to 0, R is less than len of nums R plus plus. If nums of R is equal to 0, increment the count, and then if count becomes greater than 1, then while nums of L is not equal to 0, sorry, no while here, for row, then keep incrementing res. Now I told we need to surpass the 0, so increment L again, surpass, decrement the count because that 0 is no longer in the window, decrement the count. Sorry, I don't think I have initialized count here, too many variables. Okay, now just update your res. Size of the window is L minus R plus 1, but since we are deleting one element, L minus R. Oh, I don't think I need R here. Yeah, this should be it. Yeah, time complexity is O of n because we are just going through the array ones. Space is O of 1 because we just have like variables and we are not using any extra space. Thank you so much for watching my YouTube video. Please subscribe.